Hello and welcome to our video for section 10.1.4. This is all about what if it is a three-dimensional circle. We call a three-dimensional circle a sphere. So it's kind of a bad question, but anyway, today we're going to be looking at finding the volume of a sphere. A sphere is a three-dimensional object shaped like a ball. Every point on the outside of the sphere is the same distance from its center. That's also called the locus. When you get into high school, you'll hear about that. Today, you will use what we have learned about the volume of a cylinder to find the volume of a sphere. Myron, so we're going to start off with this problem right here. And let me close down my video for a bit. Okay, so 1047. Myron's family is putting a pool in their backyard. He is so excited that he wants to figure out how long it will take to fill the pool. He found the blueprints for the pool and recreated the sketches at Wright, but he is not quite sure how to use them to find the volume of a pool. What three-dimensional figures does Myron need to be able to find the volume of before he can determine the volume of the pool? So please pause your video, write down an answer. What three-dimensional shapes does he see in this picture? The shapes that I see are a half of a cylinder. I'm going to pull that out of the way. You can kind of see that this is like taking a can and cutting it right in half. And if you take these two pieces here, so there's half of a cylinder. Let me move that part over here. And I'm going to take this end cap, and I'm going to take the other end cap and pull those pieces together like so. And you can see that that's going to be half of a ball or half of a sphere. There we go. So if he can find half of a cylinder plus half of a sphere with the dimensions listed in this picture, then he can know the volume of the pool in cubic feet. If you're looking at these dimensions, just kind of a quick adjustment here. The 40 feet in this picture is from here to here. The 10 feet is the depth of the pool from here to here, which is also the radius of that sphere. The 20 feet that they're showing here, that is going to be the distance from here to here, or along the edge, if that helps you. That's going to be this distance. And it's also 20 feet across. So if it's 20 feet this way, that would give this part a radius of 10. So let's use those, we'll use those later on to find the volumes. In order to find the volume of this, we need to find the volume of a cylinder, which we know, that's base area times height, and the volume of a sphere, which we don't know. So let's go to figure out the formula for a sphere. 1048 and 1049, I'm going to kind of do them all in one motion here, so you can take some notes on this. In order to find the volume of a sphere formula, we're going to use the volume of a cylinder formula that we already know. So in this picture here, this sphere would perfectly fit inside this cylinder. See how they have the same radius right here? And because they have the same radius, then the ball would fit perfectly in this slot. Now, this height here is based off of the height of the sphere. So if you go from the top of the sphere to the bottom through the center, we also call that the diameter, right? So there's the diameter of the sphere, and that is the height of this cylinder. Now, a diameter is also two radiuses. So I know that the height of this cylinder is 2r, and so is the diameter. If I were to try to put this ball into this sphere, it would touch here, and it would touch down in the bottom middle, and on the side, and on the side, and it would form a sphere like so. Not too easy to draw with this tool that I have here, but you can kind of see it in there. It would fit perfectly into the bottom of that cylinder, or inside that cylinder. So knowing that, They asked, how is the diameter of the sphere related to the diameter and height of the cylinder? The diameter of the sphere is the height of the cylinder. And you could say that. So diameter of the sphere equals the height of the cylinder, ER. Part B, what part of the cylinder is filled by the liquid from one sphere? So we are going to fill this sphere up and pour it into here and see what part of the cylinder is going to fill up with the water that's in the sphere. So watch this video really quickly here, hopefully. Cylinder. Here's a sphere. Put this cylinder so you can see it. It fits perfectly on the top because they have the same radius and diameter. Perfectly in there. And they have the same height. So the bottom of the sphere goes to the top of this. From the bottom of the cylinder to the top of the cylinder is exactly the same. Take this and we're going to fill it up with water. Pour it into the cylinder. And we're going to see what fraction, what part of the cylinder fills up with the water that's in there. I think it's going to be the whole cylinder. Half. 1/3, 2/3, 3/4. It's 2/3. What part of the cylinder is filled with the liquid from one sphere? So we are going to write here, this is for 1048 part B. The sphere is 2/3 of a cylinder. 2/3 the volume of a cylinder. Part C, based on the demonstration, describe how the volume of a full sphere compares to the volume of a cylinder. I think that's basically the same exact sentence we just had here. So we could do it this way. The volume of a sphere is equal to 2/3 the volume of a cylinder. Now, we're going to take this idea and use it to write the equation for the volume of a cylinder. And this will be my 1049. So part A, if a cylinder has the same diameter and this height of a sphere, what is the relationship between their volumes? Okay, so we just did that. We said the volume of a sphere is equal to 2/3 the volume of a cylinder. Part B, write an equation relating the volume of a sphere to the volume of a cylinder. Okay, so this is kind of A and B right here together. Here's A and B. Part C, if the height, actually we need to actually take this and go one step further. So the volume of a sphere, which we don't know, is going to equal 2/3 of the base area. Well, the base area of this cylinder is going to be r squared pi times the height. Well, the height of this we know is the same as the diameter, which is 2 radiuses. So if this is 2r, then this is times 2r. So basically we're answering actually A, B, and C all here. So if I take 2/3 the volume of a cylinder, that's this volume right here, r squared pi times the height, which was 2r, then the volume of a sphere is going to be 2/3 of 2r cubed pi. See how r squared and r to the first would make r to the third power? And there's a 2 there. So the volume of a sphere, if I multiply this out, is going to be 4/3 r cubed pi. Most textbooks say this. They'll say 4/3 pi r cubed, and that's what you will normally see. So you're going to cube the radius, multiply it by pi, and then take 4/3 of that. This is the formula for the volume of a sphere. So to make it nice and clean, we know this. The volume of a sphere is 4/3 r cubed pi. Here's a little side question. What is the volume of a sphere with a radius of 10 feet? All right, so I know this is r. Here's my 10 feet. So I'm going to say the volume is 4/3 of 10 to the third power pi. 10 to the third power is 1,000, so this is 4/3 times 1,000 pi. So the volume is 4,000 pi over 3 cubic feet. Now we could get a decimal value for that. We take 4,000 times the pi button on your calculator and divide it by 3. Since this is near 3 and this is 3, I bet you the answer is going to be somewhere around 4,000, maybe a little bit more. So now we know the volume of a sphere and how to use that formula. Now let's go do the problem we had at the beginning. Use what you've learned in the previous problem to help Myron calculate the volume of the pool. So we know from the previous problem that if we take this piece and this piece, this piece right here, and we put them together, that we're going to get half of a sphere along with the cylinder, half of a cylinder. If we can get the volume of those two pieces based on these dimensions, then we can tell the total volume of the pool. So let's go do each piece here. The volume of this sphere is 4/3 r cubed pi. We need to know the radius of this pool. Well, there are a couple places we could get it. We could get it from here. If the diameter is 20, then that would make this 10. Or we could also get it from the depth of the pool. We know that this part right here is going to be 10 feet deep. So I know this r is 10. The volume of this sphere is 4/3 of 10 to the third power pi, which we did on the previous page, which we know is 4,000 pi over 3 cubic feet. The volume of the cylinder. So yesterday we learned the volume of a cylinder, or the previous lesson, was the base area times the height, where the base area is a circle. We want to get half, oh, I'm sorry, I made one other mistake. I need to find half of this problem. So the volume of a hemisphere is going to equal half of the 4,000 pi over 3, which is equal to 2,000 pi over 3 cubic feet. All right, now I'm feeling better about that. This problem, to find the volume of this half cylinder, we're going to take half of the base area. So we have a radius of 10. So that's going to be half of a 10 squared pi times the height. If you were to turn this over on its side, it would stand up 20 feet tall, because we know that from here, times 20, there's the height. So the volume of this piece is going to be half of, let's see, 100 times 20. 100 times 20 is 2,000 pi. And if I take half of that, I get 1,000 pi cubic feet. So the total volume of this pool is going to be what we get if we take 2,000 pi over 3 from the hemisphere plus 1,000 pi. Let's see, that's going to be 2,000 pi over 3 plus, if I get a common denominator, I could triple these. 3,000 pi over 3. So I know that that's going to be 5,000 pi over 3 cubic feet. This is the total volume of that pool. We can get the decimal value. The volume is approximately, let's see here. I'm going to take this calculator and say 5,000 times pi button divided by 3 is approximately 5,230. Let's call this 6. That's so close to 1. 5,236 cubic feet. 5,236 cubic feet. So there's the approximate value. I still like the exact value better. Now, problem 1051. If there are 0.1337 of a cubic foot in 1 gallon, how many gallons of water will it take to fill Myron's pool? So let's see, every 1,337 ten-thousandths of a cubic foot is equal to a gallon. In a gallon. So I'm going to put 1051 right here. If I take 0.1337 cubic feet for 1 gallon, and I know I have a total of 5,236 cubic feet. So I'm going to have to take this. Oh man, okay, so I'm going to have to take the 5,236 cubic feet and I'm going to divide that by 0.1337 cubic feet per gallon. And that's going to tell me how many total gallons I need. So let's see what we get here. 5,236 divided by 0.1337 equals 39,162.3 gallons. 39,162.3 gallons. Nice. That's a lot of gallons. Problem 1052. Since Myron wants to know how long it will take to fill the pool, he needs to know how fast water flows out of the hose. He gets an empty gallon jug, turns the water on as high as possible, and finds it takes 6 seconds to fill the jug. At this rate, how long will it take to do the entire pool? So 1052, he knows that it's going to be 6 seconds per gallon. So we have this many gallons. If we take 39,162.3 and multiply that by 6 seconds for every one of those gallons, it's going to take a total, let's see, 39,162.3 times 6 is 234,000, what was that? 970, let's call it 974 seconds. Now, we should probably turn that into like hours or days or something, see what we get. So let's take that number, 234,974 seconds, and we're going to divide that by 60 seconds per minute. So let's see what we get when we do that. If we take that divided by 60, that would be 3,916.23 minutes. Let's take that and turn that into hours. So I'm going to take Let's see here, 3,916.23. And let's divide that by 60, and that'll be how many hours? Divided by 60 is 65.27, 65 point, let's call it 27 hours. And let's take that and divide it by 24. And we'll see how many days it takes. So if we take that number divided by 24, we get 2.72 days. 2.72 days. Almost 3 days to fill that pool. That's a lot. All right, get that hose running. And then the last problem I'm going to throw at you here, 1053, if a sphere has a volume of 36 pi cubic feet, what was its radius? So we could start backwards. We know the volume formula for a sphere was 4/3 r cubed pi. If I know this is the volume, what's the radius? So let's see, 36 pi equals 4/3 r cubed pi. First thing I'm going to do is I'm going to divide both sides by, I don't know, let's divide them both by pi. Let's get rid of that pi. So now I got 36 equals 4/3 r cubed. Now what I'll do is I will multiply by the reciprocal of 4/3, which is 3/4. So if I multiply by 3/4 and I multiply by 3/4, then I get a giant one here and a giant one there. So I am left with 108/4 equals r cubed. Bring it up here. So r cubed, 108 divided by 4 turns out to be, is that right? 108? Yep, 108. Be 20, what is that? 2, remainder 28, 27. And we also know about cube roots now. The cube root of 27 is 3, so the radius must be 3 feet. Your job is to go do 54 through 61. Thank you for listening.